This is an AMS podcast sponsored by Mitsubishi Electric. I'm Nick Holt, editor at Automotive Manufacturing Solutions.
Hello and welcome to this AMS podcast. Vehicle producers are increasingly introducing new areas of automation on the shop floor, and this is being supported by advances in robotics, software and data management. These developments are transforming production planning processes, tooling and robotics from enabling more flexibility in trim and assembly, high accuracy in metrology, and implementing fleets of automated guided vehicles and smart transport robots, and also rolling out predictive maintenance applications. So to find out more about this and how these new developments are being applied in manufacturing operations, I'm joined by Majewski, Director, Global Key Accounts, GKAM Automotive, Factory Automation at Mitsubishi Electric. Welcome, Lucas. Thanks for joining me today. Automation's obviously been in automotive for decades. It's kind of been an exemplar of the use of automation. There are developments and challenges and demands now in the industry that are now seeing a greater emphasis on it. And there are more opportunities, it would seem, in implementing far more advanced and sophisticated automated systems. Could you sort of give us a sense of this and, you know, some of the trends and drivers around this?
Okay, so thank you, first of all, Nick, for giving me this opportunity to discuss with you about this very, very interesting topic. If I summarize, those trends, we can say drivers in the automotive manufacturing when it comes to automation, we can first talk about the automation of processes and tasks, which is one of the key area when implementing, robots and now cobots. That gives greater flexibility to the customers. Then second, and probably one of the most important, is data-driven automation. So data-driven automation of decisions. So how, having information on the production, on the machines, and other information coming from the manufacturing lines can help taking better decisions. And the third one will be I can say, integrated automation ecosystem. So it's, I would say, some, visualization or process visualization tools that helps providing some insights to the process engineers, to the maintenance managers, to the plant managers on their production line, etc. So like a central, we can say, maintenance or information tool system for the automotive customers. So these are more, I would say, related to the manufacturing. But if we look at, the main drivers on top of that, we'll have the quite similar to other industries, like manufacturing costs should be reduced. Of course, improve the quality. This is always, top of the KPI for our customers, to reduce the non-quality as much as possible, to go for a sustainable development. Again, minimize the energy consumption, waste, etc., and reduce the footprint. So that's, I would say, the most common for the whole industry growths and drivers.
And it's interesting because the challenges of reducing costs and achieving sustainable production are big challenges. It's an incremental change we see with this. I mean, one of the questions I did want to ask around this sort of increased impetus, obviously there are two key things. Do you think that the recent challenges raised in the last 18 months, or possibly a little bit longer, with the pandemic has kind of accelerated that sort of move towards, or drive towards greater automation or the adoption of some of these new systems? Do you think that's been the case?
That's a very good question. And if we look what happened already before the pandemic, we have seen that already many automotive customers, so in the automotive industry, there was already a trend of adopting digital solutions, more flexible production methods using cobots, etc. And as you mentioned, due to this pandemic, it definitely accelerated this adoption of those technologies. So the digitalization, cobots, robots, etc. So it already started in the past, but now it's really been accelerated. So we see a greater, and faster adoption of these technologies because before we have already seen, the benefits, but now they are even more visible, and it's more well understood by all automotive customers. So it's really an accelerator of new digitalization and flexible production methods. So again, cobots, digitalization, like with data collection and so on. Yeah.
From Mitsubishi Electric's position, do you feel that because you have these new technologies, these developments have been ongoing, do you feel now that you're very well placed, or the automation industry is very well placed to now service this increased focus and demand from your clients, the tier suppliers, the OEMs?
So we are in the factory automation area since many years, and had already I would say wide portfolio to cover these needs and requirements from our customers. And that it's true that this pandemic accelerated the investment in those key areas where we can provide the solutions. I mentioned several times the cobots and data analysis, data collection systems. That these are two, key area where Mitsubishi Electric has a strong value proposition for the customers. We have already, showed the advantages and benefits of using those technologies in production lines, in power and train shops, etc.
Two things you mentioned there: digitalization and flexibility. Touching on digitalization, as you say, it's been ongoing for a while. Could you just shed a bit of detail on how digitalization has supported automation, and if you've got any sort of examples of like just particular areas of production that might be useful for that?
Digitalization is a wide topic, we can say, because we cannot talk about the digitalization, of the whole plant, of the production, of the product, of the maintenance, simulation, of the whole installation, etc. So there are many key topics. Mitsubishi Electric, so factory automation experience is that we suggest to start, with some clearly identified applications. So not trying to run the whole digitalization of the plant, because when you see too big, it sometimes takes too long to be implemented, etc. Based on our experience, we strongly suggest to start with a small application with clearly identified issue or problem that we are going to solve, and start, for example, with simple data collection. So to provide like an IoT solution or IoT integration at a machine level or at a production line level, just to start understanding what is going on the line. Then, as a next step, after we collected this information from the production line, and we are starting to understand what is happening, is to apply some intelligence, I can say, to this data, some statistical methods to compare with some references, or even going, I would say, further and implementing some artificial intelligence. So, for example, what we can do is, or what we did in some production line is, we were able in some specific, production line is to make a link between the inputs of the production line. So, for example, humidity, torque, power consumed, etc., with the quality of the product. So we were able, after a few months, to define that, okay, based on these inputs, if you keep these inputs at the right level, you have some threshold and you keep it at this level, then we know that the quality will remain unchanged. And this is, today very powerful, because, with small inputs in the very beginning of the production line or on this machine, you are able to define that it will impact in some way your final product, the quality, at the end, the quality of your product. So there are basically two, I would say, benefits in using those solutions. You have the predictive maintenance that you will be able, to foresee, to forecast and to define some potential failures that may happen, and also the quality, because if you are able to keep the inputs at the right level, then you know that the quality of your product will remain unchanged. And this is really, really powerful solution.
Another big thing we're seeing with car makers, tier suppliers, especially now the move to EV, and flexibility in production. Now, I know from my conversations from the years I was kind of visiting car plants that robots were not always seen as the most flexible solution. They were the most reliable. They were very consistent, but they weren't, because of the issues with programming, the sophistication of the software, the dexterity of them. They were kind of very limited for quite a while, but that's changing now. And if we take the sort of move towards electrification of the vehicle product lines, and particularly the powertrains is mainly the key thing, the motors and certainly the battery packs. How important is the role, do you think, of automation in enabling the flexibility that is now required in manufacturing to produce, for example, multiple powertrains in a single plant, or even an assembly line, which is challenging, moving from ICE to electric?
Yeah, one of the key development area here is related to cobots, because as you mentioned, robotics have been used, in the automotive industry since many years. So it's not really new. There are some new advantages and benefits when you can have some, I would say, automated or self-programming of the robots, so they can adjust, their path based on the obstacles they may discover or find around around the robot or themselves. And the second is the cobots. They give a greater flexibility to automotive customers. You mentioned powertrain, and this is a good example when, for example, now it's faster and I would say easier to implement such products because it requires less. For example, I would say it's not in a cage like robots in the past. They were moving in a cage, so for safety reason, it was not possible to go around the robot. And I would say it was well automated, but flexibility was not there. And now with cobots, you have these flexibilities because people can work around, can work with, and now cooperating with the cobots. And when I mentioned that it's easy, so it's today really easy to program the cobot, because it doesn't require for you to write specific codes. You do not need to know a specific programming language. It's a simple drag and drop programming, so it's very easy, accessible to any people. It's extremely flexible and easy to use, and again faster to implement because you do not have so many safety necessary requirements around, like we had with robots that are working in some cages. So this give a lot of flexibility to automotive customers.
We've seen cobots again for a little while now. They've been around, but they've kind of not really been broadened out. I mean, you mentioned there it's a much more accessible technology now in terms of what's available to the car makers. Do you see a larger broadening out of the application of these across tasks that they hadn't previously done, or are they still limited to the kind of very lightweight, delicate sort of operations?
That's a good point. Cobots are still, I would say, not new technology in the sense that it's new, but new in the sense of the implementation in the automotive industry, because it's not implemented since so many years of the robots. But it's, as you mentioned, the number of applications covered by cobots are increasing. That's true. Since there are many now cobots having higher payload, it's easier to manipulate some products that are quite heavy, etc. So it's going to be developed more widely in application where I would say 2-3 years ago it was even not imaginable. So now we can easily implement to many other areas. So that's giving more flexibility to automotive customers again.
The technology is clearly there. From your perspective, when you're working with your OEM and tier supplier clients, what are the biggest challenges for them to adopt and implement and deploy cobot? Is it purely the legacy systems and the planning of the plants is not kind of conducive to bringing them in, or what do you see as the challenges there?
That's a very good question, and based on my experience and our experience of Mitsubishi in the automotive industry, I remember that a few years ago, most of the customers were accepting somehow having return on investment of two years, 18 months, etc. And now we see a clear, challenge or trend that your solution, and it's not only applicable to Cobot, but your solution has to, has to present a return on investment in less than 1 year. So typically in one full budget year, it has to show the benefits of the investment. And this is one important challenge, is to be able for our customers and also for us to justify how in application A or application B you can easily show that the investment is interesting in less than 12 months. This is a clear challenge and trend now in the industry.
Something we touched upon at the beginning, digitalisation and data management. That's probably one of the most transformative things in automation, since it creates a very transparent map of the operations, what they're doing in terms of following any issues with quality control, with performance, with takt times, things like that. Could you just give us an insight into some of the areas that have been optimized by this sort of digitalisation and better data management?
Thank you. That's one very good question, because with digitalization progressing, we see one very important challenge is how to handle and how to store and what to do with this huge amount of data that is manipulated and stored, because when implementing these IoT solutions, we are able to collect more data, and I think what automotive customers needs to find or to define the right balance between processing the data on the edge, so as close as possible to the machine, and storing the data in the cloud or in also some servers on their manufacturing plant, because this in Mitsubishi Electric's opinion a right balance to find between storing simply the data in the cloud and process it, analyze it when required. For example, when you have some recalls, when you need to recall some cars, thanks to the data you collected from the manufacturing line, from the production, you are able to target somehow the right cars or products that have some issues or that potentially have some issues. So you're able to target more the defective components using this data. And on the other side, so this is for the cloud and the data that you can manage later. This is one of the usage. And the second one is when you process the data as close as possible to the machine. We talk about edge, processing, edge computing. It sometimes requires to act very quickly when, for example, you see a defect on a product, in order to not continue with the same product or with same issues along the new product that are coming, is to being able to identify the issue and react as fast as possible. And what we at Mitsubishi Electric are able to provide right now is, when, as I mentioned, we collected the data, analyze the data, process the data, we can feedback the result to the machines. So it means that it can autonomously, it's autonomous production, that it can adapt itself to the production. When we detect the issue, we adapt the machine, we correct it, and we reduce the number of waste, of defects in the product, etc. So this is now, producing insight that can be used to make smarter decisions and timely actions. And this kind of solutions are, it's feasible, it works, and this is possible without human intervention. So these technologies allow today to do this kind of improvements in the manufacturing lines.
The automation of automation. I've heard this term being used. So the data is being used and instantly reused and shared across a network of robots from one cell to a number of cells. One of the things I was going to ask, there's this sort of sense of, let's take robots for as an example here, of rather than being a programmed and even a fairly smart unit, that they become connected devices almost, that they can share this data. Is that a trend? Is that something that's going to enable this? And the second part of my question is, again, another thing we've heard that's apparently going to make, or is going to make, a dramatic improvement in automation is 5G connectivity. Because you lose that latency, you can have almost instantaneous transfer of information
That's a good question, and it refers to the third point I mentioned, in the trends and growth in the beginning about more integration, more integrated automation ecosystems. That all this data that you manage are also collected and somehow centralized in a main system, because if we were able to identify some issues, it's important that we can capitalize on that and reuse it for future improvements. So we know that when having this deviation, we know that it may finish with this problem or another problem, etc. And we are able to implementing this improvements in a central I can say tool. We can easily share this information with all the plants that are connected to the same tool. So it's basically, one application will improve the others similar in other factories, in other solutions. So it's very powerful, of course, but the challenge here is to, make sure that your connectivity is the same in all the plants, in all the factories, etc. That you are able to share this information and data between one machine and another, and also between the people you have using in one country and in one other country, that they have the same understanding of the different data they have in front of them. So that's the first point. Second, you mentioned about the latency, etc. Good comment. With current solution of Mitsubishi Electric, we are able to provide real-time data analyzers. One example, we are using, network technologies like CC-Link, i.e. based on TSN technologies, will gives a great flexibility and again, the real-time possibility, real-time data analysis, which is extremely powerful because it already reduces the latency. And if we can talk also about the cyber security, since it is as close as possible to the machine, it's also protected somehow from the external potential threats we may have. And next point is about the 5G. So I believe also that 5G will unlock some addition, I would say, improvements for the automotive technologies, because it will allow faster communication between the different machines, production between the people that will use, for example, smartphones, tablets, etc. So it will be even faster, I would say, reaction in the manufacturing line.
I mean, some of the bigger OEMs, I think Volkswagen have been particularly open about the fact that they're setting up these industrial cloud networks that are linking their global manufacturing operations, which span hundreds of plants in some instances, to create this kind of properly functioning and optimized network, global network. Where do you see the need for operating protocols, standardized operating protocols for IT software, robotics particularly, so that everyone, no matter whose robots they might be, they're all operating on a similar platform? Because obviously with a lot of different proprietary softwares and systems and setups platforms, that can be challenging, even in a factory, if you've got multiple vendors supplying into that.
Good point. I would like to link, this question to the previous comment about the more integrated automation ecosystem. I would say to make it the most effective and reliable, it is important to define, as you mentioned, some standards. Because collecting the data, I would say in current days, it's quite easy. But how do you collect the data, and then how do you manage the data? How do you present the data? It's one of the most important, I would say, requirement for this kind of system, is to ensure that the way you structure your data and to present it, the parameters you use have to be definitely the same from one, I would say, machine to another. We can take an example with robots. If you would like to collect the data from robots today, as I mentioned, is quite easy. You can easily collect this information from the robot, but then you would need to ensure that from manufacturer A to manufacturer B, what are the data you would like to collect? Because from one to another, it may be different. All have their values and advantages, but you as an, I would say, end user, it's important that you have your, I would say, template. We can say, template that will be the same from one to another, so you can easily make this comparison. And that what will impact your production, your product, your machine, etc. So it's important to have these templates and define some standards, how you collect the data, how you manage the data, how you structure your data, how you present the data, and at the end how you can optimize your production using the same information presented in the same way. So this is a key challenge, and some of the existing networks, I think, can solve these issues right now.
At the minute, we're kind of dealing with issues that have come around, two things really, perfect storm of a pandemic which has disrupted supply chains massively, and we've also got a massive change now from one generation of vehicles to another with a different powertrain and a different outlook, so the volumes are different. At the minute, the volumes and capacity of production is kind of peaking and troughing massively, which is not something car manufacturers like. So my one question is, do you see this leveling out a little bit in the next few years as things settle down and because the sort of types of product become more standardized, the demand for them is more even? And also, where else do you see automation going and sort of penetrating into the manufacturing operation?
I believe that we will continue this automation because there are still many areas in the automotive manufacturing that can still be, improved. I think also that digitalization will continue to be spread around, the factories, because again, I would say that currently we see it's a 40% automotive customer that have already quite well automated and digitalized their production, and 40 just started. 10 and 10, I would say, not started, and 10% are really, really well, I would say, digitalized, that have, as you mentioned, clouds, IoT connectivity for the machines, already some improvements using data intelligence, like artificial intelligence, etc. What I also think will be important is to have no more fixed production lines. I mean, currently we can have some fixed production lines that are not so flexible. You have some flexibility, but when you need to make a new car or some new options in the car, it really requires to completely rethink or modify this production line. So I believe that we will have some modulars or some modulars or cells that can be moved from one production line to another. So it will I think it will no longer be a fixed production line. It will be modular, that it will adapt to the customer requirements. What I also believe is that in the next few years, I think that we will be able to, for example, you will be on a website or your mobile phone selecting a car. You will select an option, and this information will be automatically, transferred to the production line, and your production line will adapt itself to ensure that, for example, you choose a specific color, I don't know, another option, and it will adapt this production to your requirements. It will ensure that your car will be designed as you suggested. So it will give even more flexibility and more, customization possibilities to the customers, to the consumers. So this will require, again, this modular, production, etc. So that's, I would say, the key areas I see. And when it comes to pure automation, I really believe that in the next years, maybe next few years, but next years, we will go even more deeper in a more autonomous manufacturing, that, again, using all this amount of data, information we have from the machines, from the product, from the customers, we can, adapt the production lines, consume less energy, be more sustainable, reduce the footprint, improve the quality, etc. So this, I think, the area will be improved and more developed in the next years.
Okay.
This was an AMS podcast sponsored by Mitsubishi Electric. Thank you for listening.